Today, I'm going to show you how to make your own CO2 sensor for dirt cheap for under 30 bucks. Maybe even cheaper if you buy everything in bulk like I do. So here are the basic components. You'll need a USB charger, the micro USB cable to power up the chip. This is the D1 Mini, and here's the CO2 sensor itself. Here's a quarter for comparison, just to let you know, for you to see how small everything is. I know it's not nice and pretty right now, but I'm going to make it nice and pretty later on. All of these components can be easily hidden in a 3D printed case, or you can buy your own case from Amazon as well. If you grow your own garden indoor, then you know exactly how important CO2 is. Conversely, if you're in a basement or somewhere that's not well ventilated, then you know the side effects of CO2 can't be good for your own body. With too much CO2, some side effects include headaches, dizziness, restlessness, a tingling or pin or needle sensation, difficulty breathing, sweating, and tiredness. Worst case scenario, you're going into a coma, asphyxia, and finally, convulsions. None of those are good. Strangely, CO2 sensors are ridiculously expensive. Here's one by Nitamo, $100. Yep, that's a lot of money. I know for sure we can build something better and a lot cheaper. So all we need is 4 wires connecting this chip to the sensor itself. 5 volts from here goes into the V-in. Ground from here goes to ground in the sensor. On this receiver, it goes to the transmitter. And conversely, the transmitter goes towards the receiver on the sensor itself. And that's it. All you need is 4 wires for the chip to talk to the sensor and back and forth. Now, I'm going to assume you have ESP Home installed already. So go ahead and click on ESP Home in Home Assistant. Go to New Device. Click on Continue. Name it whatever you want. Click on Next. Choose ESP8266 because we're using the D1 Mini. Click on Skip. Next, go to the Edit. Once you click on Edit, you can highlight all and then delete everything. Go ahead and open Notepad and start editing. You can use the template here as I've shown you. So the first section is the name, whatever you want to call it. The platform is ESP8266. The board we're using right now is D1 Mini. Logger : API password, whatever password you want to use. OTA password, whatever password you want to use as well. For Wi-Fi, type in the SSID of your network. The password is the password that belongs to that SSID. The IP address, you should set it up to be manual, to be static. In this case, it's this number right here for my network. Because this number right now is a blank. It's not being used. The gateway is the gateway of your router. I'm on Verizon, so it's 192.168.1.1. This subnet is for Verizon, so it's 255.255.255.0. The access point, just in case this chip cannot get onto your network, then it's going to spit out its own SSID and a password to jump onto that SSID. The bottom section is specific to this CO2 sensor, and it's just copy and paste for you as well. You can rename the name if you want, and that's basically it. Now that you've edited the file with your own notepad, go ahead and copy everything and then paste it back in here. Click on Save and then click on Install. Click on Manual Download, Modern Format, and it's going to start compiling. This step takes a while, so go ahead and get yourself some ice cream. Now is a good time to plug the D1 Mini with the micro USB into your desktop or laptop. Make sure that the sensor is not connected to the D1 Mini, so it's just bare D1 Mini with the USB cable plugged into your desktop or laptop. Now, to find out which COM port the D1 Mini is on, go ahead and go into My Computer, go over to Device Manager, or from the Start menu, start typing in Device Manager. It's going to open up Device Manager and go down to Ports. Here you can see the device is on COM port 15. Now, to actually install the firmware that it created, which is the bin file, go ahead and open up Microsoft Edge. It has to be Microsoft Edge. I think Chrome will work, but Firefox will not work, so don't use Firefox. With Edge open up, go ahead and go to web.esphome.io. and then click on Connect. It's going to ask you for the COM port, so go ahead and select the COM15 or whichever the USB serial is connected to. Go ahead and click on Prepare for first use, and it's going to start formatting and start doing its thing, wiping up everything. In actuality, you might not even need this step, by the way. Click on Close. Now click on Install. Choose the file. Choose the bin file that I created earlier, and then click on Install. Now that the firmware has been installed on the D1 Mini, go ahead and unplug it from your computer and then connect it to the sensor using the 4 wires that I showed you earlier. If you want, you could connect the D1 Mini up to your computer again, or you can always connect it to any USB power plug. To set this device up working with HA, go to Settings, go down to Devices and Services. You should see that it's automatically found the device, so click on Configure, click on Submit, and enter the password, the OTA password. Click on Submit, and there you go. It's connected to the D1 Mini successfully. Assign it an area if you want, and then click on Finish. Go down to ESP Home, click on Devices, and there you go. The CO2 device is now added in. It might take a while for the sensor to warm up to start giving out the proper values, so don't be alarmed when you see unknown value. So right now I'm sitting in a very large room, so the CO2 value is about 500 ppm, parts per million, and the temperature is about 72 degrees Fahrenheit. That's correct, because I have another thermometer that's sitting right next to me. If you're ever curious whether your CO2 sensor is working properly, you can go ahead and stick it out the window. The parts per million should be in the 400 range. So right now I believe my CO2 sensor is working perfectly fine. If this number ever goes up above 1,000, then I set an automation to have my fan spinning to spread that CO2 all around. If you're curious how that works, go ahead and check out my video on setting up the fan automations. Let's click on it right now to see what the history looked like. Yesterday, when there's a lot of people in the room, it's about 700. When I went to sleep, it went down, it dips down to about 550. And here we go, when there's a lot of people in the room, in the house, it kicks back up to about 700. So yeah, using this sensor, you can actually tell when there's people around here or not. Pretty slick, right? Alright, hopefully this video helps you how to set up your own CO2 sensor. I really appreciate you guys subscribing to my channel, liking the video, and thanks for watching.